we give one brain image. Ask it to classify whether it is having tumor or it is normal. We give kidney image, whether it has a cyst, stone, normal, or what is the status of that. Okay. So in case of machine learning, we give the output and the data. It has to find out what is that. We have say program is to multiply. I'm talking to the simplest form of things. Okay. So here we train the model with a different pixel set of data set. Now what is happening? I give the input as a cat. You should say that output is given as a cat. Output is a cat. Okay. I know that it should give the result that it is a cat. That means it should classify it as a cat, not the dog. Okay. So we have many layers in between, convolution layers, or some downsampling, and so on. Some layers we design, and the output is decided based on the probability statistics. See, all of us have agreed that mathematics is the biggest tool, and we are making use of that. They say that probability, if highest probability, take it as that. Suppose cat is having a 0.6%, dog is having 0.4%. They say that it is a cat. Probability. So ultimately, in case of deep learning also, we make use of probability. Here what is happening? We have made use of two things. Input given is a horse and the zebra texture. See, zebra texture is given. Output is horse with zebra texture. Program to add the animal texture to a selected animal. We have added texture only that. But what we feel? Stop looking at this horse. We feel that it is a zebra. This is one way of generative AI. Today we talk about generating. I have generated the zebra from horse. Why? I wanted to say check how the pattern. If I put the texture on the, I can also put the texture of the lion, texture of the tiger. People will laugh at that. Generative AI, if I ask the texture of tiger on a horse, the same thing instead of zebra, there will be a texture of the tiger. People will not agree that. I said Iron Man of Iron Lady. Okay, we don't accept that. Iron Lady is Iron Lady only. So now you can observe. People can experiment like that because the industry is like that. See, for example, in fashion industry, you have generative AI, people may recognize, oh, this is very good. In our native place, earlier there were handlooms. Today we have power looms. Every day 3,000 sarees will come out. My native place is Sigli. Government of Karnataka has given them a free power, electrical power. See, nobody. Gujarat, Rajasthan, those people are afraid of competing with Sigli because Sigli people are getting free power. And that is why it is taking the bread. So, like that, what I mean to say that when there is something that is good, we can, when people come to Shiglina, why I'm telling you, oh, I want this texture and this border, this design. I have given design of zebra texture with the horse generated good, but somebody will ask, I want on horse the tiger texture. Doesn't matter. Doesn't matter. The powerful people will manufacture that. Okay, you say dollar, I'm gonna border this conditions, they fulfill it because it's a business. At the same time, putting a lion, okay, texture of tiger on lion to certain extent it matches. Okay. Artificial neural network, all of us, this is the FDP where people are better than us. Okay, I consider the foundations are already there and I proceed further. Okay, why I am showing this is these are all decision making activation functions. Okay, we make use of the probability and then we select the best and then we classify. My interest is not this. There is a see here. Before finding a solution, by neural network to the XOR gate. XOR gate, okay, it was like a hidden layer. People used to neglect that. Oh, neural network, it cannot solve even an XOR gate. People used to laugh at that. That's why I keep telling people that if the people laugh at you, okay, take it as a comment, positive comment and work hard. See, people have worked hard and they solved all the layers. This implementation of logic gates, but at the end, they also got the what is this logic not? Then we have XOR. XOR was solved. XOR was solved using two layers. Everybody was started trying to solve with one layer, unable to. Somebody, oh, I can use two layers. They solved it. That is the first success towards deep learning today. So this is the one which has given us, okay, the solution to the XOR gate. I hope all of you know the XOR gate, how it functions. So basically, we come across, we input with many layers. Today, we talk about so many layers, okay, and that is why we call it as deep learning. We classify them as men or horse or whatever it is. Coming to VCC, I will touch upon these things quickly. VC16 convolution neural network from classification, you can observe that at the end they have only 1 cross 100,000. 1 cross 1000 because there are 1000 objects. Each object will have one value. One value. Whatever the object I give in the input, suppose if I give apple, assume that there are 1000 elements, objects, it should recognize it as apple. If I give element as object as mango, it should give seer. At the end, there is only one value for every object. So therefore, this VCC is making use of convolution and ReLU function for making decisions. Max pooling. Max pooling. See here, very, very important. Max pooling is downsampling. They extract the features and then using max pooling, they downsample. Suppose I have assume that I have say 100 by 2 by 100 or 4 by 100. I remove some two rows, I take only remaining two rows. That means there is a loss of some data. There is a, when I make a max pooling, definitely I am losing some information. When I lose some information, no doubt you can lose, but you cannot reconstruct back. Like DCT, FFT, and Violet transform, just now I discussed, we cannot reconstruct back because this is not a transform which is, capable of reconstructing back if you lose the some rows, irrespective of which row we make use of. Similarly, this is a diagram, we get the output. ReLU function commonly used activation function, okay, max of 0, x. Whatever it is, irrespective of which activation function we make use of, they are based on probability. The activation function, after using, if the value is greater than 0.5, more than 50%, whatever it is, or the highest probability, it select it as that object based on the probability. So when we make a downsampling, we are losing the information. When we take a FFT, we are not losing the information. When we take a DCT, we are not. I have shown them. I have reconstructed back the Lana image using DCT. Just now I have shown in the beginning. In Violet transform also I can reconstruct the data back. Here I lose so much of information, fine, but at the end, without that I can do that. Okay, this is the convolution which we are making use of. So, main part of deep learning is convolution. Now, I give you this right side convolved feature, we cannot construct back. Knowing the, what is that? Mask. Knowing the mask, we are getting this. But After this, I give the mask, will not be able to reconstruct it back. Okay, so we are losing something. You can observe there. There is a filter or mask. We are getting this is 5 by 5, 25 elements are there. I am getting the output as 3 plus 3, 9 elements. Using 9 elements and the mask, I cannot reconstruct back. That is why first I executed DCT, discrete cosine transform, with a little few number of coefficients I am able to get back. Dr. Tanuja Patil has published one paper in image processing, seed-based image compression. Okay, she extracted the seed of any given image, and compression takes place, and we can reconstruct that back. But steps in convolution are, all of us know this. These are the steps used in convolution. Okay, I'll come to that. Why reconstruction is to be given some importance, given in deep learning, is that has got some power to reconstruct back and see what it is. Suppose the answer that you are getting is something, say, not correct. Okay, not correct. Suppose it's a normal one, it is telling that it is cancerous tissue. We should not get the wrong answers. Using somewhere, thinking about reconstruction, we may improve the quality. That is why I said nature inspired algorithms. See here, there is a mask. We also say it is kernel. Okay, so here we have 1, 2, 3, 6, 36 values are there, and then feature map, using feature map, we cannot reconstruct that. See here, whatever it is, the data is not a small matrix. We may come across videos, medical, say videos of the heart, videos of the kidney, how it's functioning, or the image data sets. The size will be minimum 512 by 512. So when we have very big matrix and then make convolution, get a small data, we are not capable of reconstructing that. Okay, so that we can explore that. The nature has given us the ability to reconstruct that. Think about how we can do that. Okay, the similarly we have shown here how the convolution works. So this is the point where we have to think. I have a wheat, right? And then I make atta, and then we make chapati and we eat, right? Now, when I have atta, I cannot reconstruct it then. Assume that all the wheat on the earth are not used, reused, recycled, reused for growing. Okay, again, we will not be having wheat seeds on this earth. We make atta, we eat chapati. So at the end, sir, even it is 1,000 crores of quintals with the population of our within a few days or few years, it will be vanished. See, that is why when we have something, earlier farmers used to take out their own seed. Now they are depending on bio companies. Bio companies we bring with by paying a very high rate, and we grow, and then we cannot make use of those seeds. They will not give any yield. Again, we have to go to the chemical, that compound or seed we have to purchase with the companies only. That is why former leader of Rait Sangha, Professor Ranjan Swamiji, fought against bio companies. You are killing our farmers. That is why the suicide rate, increased, because people grow, then people are not educated. They use the seeds of the cotton or any other, then they put it, it is not giving yield. After spending a lot of, they never knew about that. But that is a consumption. See here, now coming to the nature's inspired algorithms, you take anything, it will give it back. ECT is giving back, WT is giving back, FFT is giving back. Convolution will never give back. Convolution, at the end, we have to eat and say that, oh, chapati is very good, parota is very good, that's all. But we should also have some algorithm where the seeds are again used back, okay, to have, the continuity of the life. Like that, convolution, I'm not say rejecting totally, it should be there. It should be there. Okay, but at the same time, we should also parallelly go for the algorithms which are similar to the nature inspired, like WT, FFT, and then DCT. That's why I could execute them. Here, I will show you one more program. Very important. See here. What is that important? First, I will run DCT, then I will run that. Then you will understand what is the importance. Okay, so look at this. Now I have told you that it's a DCT, right? So it is Lena. Only the top bright points, okay? Coefficient, DCT coefficients can be used to reconstruct that. See here, we have the beauty of we are taking very few coefficients and reconstructing that. But what is happening to Lena? Lena has become a ash. Small pixels. And then using that, those pixels we are reconstructing. That is good. That is really good. Where with a few coefficients we are getting it back. Life is there, right? But what has happened to the Lena there? It is looking as if few points are there in my hand. Seeds, I can keep seeds, and I can say that, oh, these are jawar seeds, this is rice seeds, wheat seeds, okay, pomegranate seeds. Like that, I can say, right? So coefficients are extracted here and then reconstructed. Now it is destroyed completely. Lena is not visible as Lena. Lena is visible as some dots, right? But there is one more similar to FFT. FFT also has lost the FFT. I think I will show the slides maybe afterwards. Now you can say that. Okay. Why I want to run this is I want to retain the features of the so I am also using another transform or another way of splitting. What is this? This is Lena. Is it visible? Okay. Now, how this looks? Right. But it is not like DCT. DCT was few coefficients were there at the top left corner. Here, I have taken one bit image of Lena. Usually, Lena is the grayscale. It has got 8 bits. I have taken one bit. By taking one bit, I can say that this is Lena. See, Lena. Classification is very simple. But what is the size? It is drastically reduced. I can also reduce this using either run length coding or some quadrant coding. I can still reduce, I can make a seed. Seed of one layer is hardly few bytes. But that byte is there, no? That has got the whole picture. If I reduce this to maybe 8 cross 8 or 8 cross 8, our eyes will be unable to detect. 16 cross 16, if I reduce it, I can still see the Lena image. In Violet, if I make 3, 4 repetitions, at the top corner, I can see the Lena still, it is not getting destroyed. Reverse is also possible. Size is small, size has been reduced, okay, and then, so you can observe that in Fourier, it's an addition of signals. It is, in case of Lena, it's the addition of bits at different levels. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, up to 2 to the power of 7. I have 8 bits, 8 layers I can create, and all the 8 layers will have, see, still Lena is looking. A black is whatever it is, still what I will do is I will run one more image with one more image, then we can differentiate that. See, I will then this is earlier was weightage 128, this is 64, and then 32, then comes 16, 8, 4, 2, 1. 1 has got a very high frequency. We cannot see the content, but this is required to fine tune the values so that if it is 160, it decides, the last bit decides whether it is 161 or 160. 2 to the power of 0 is 1. Very high component, high frequency, we cannot neglect that. But if you want the full accuracy, you can also make it. Okay, so I am showing you Lena. So what is the advantage of this spatial domain splitting the layers is the data size is going down, but retains the spatial structure. Image of the Lena. I will run one more image so that you can still recognize better. If I change that, I'll have to edit the. I'll try whether I have another image. I'll check. Okay, I have this. I'll change it to Barbara 512. Okay. So now you can see this is different from Barbara. I will edit the program and run. You should be able to get the Barbara image. Okay. So close Barbara 512. Is it? File. Save as bit planes Barbara. Save. I will take out this as it would have been better if this laptop was connected to the.
Want it to be
I'll
connected.
save it. Madam, ಅದೇನೋ ಡ್ರೈವರ್ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ.
ಹೌದಾ?
ಅವರು ಇವರು ಫಿನಿಶ್ ಅವ್ರು ಟ್ರೈ ಮಾಡಿದ್ರೆ he could not connect it. See, now you can see here, I hope audience are less number of audience are there. Sir, there is a category. Barbara is different from Lena. Okay. So now you can observe here, this is Barbara 8th layer. We have each pixel as sum of 1 plus 2 plus 3 plus 4, 8, 16 like that. This is the bit planes we call it as. 8th bit plane, it looks like that. Okay. Then we have 7th bit, but still looking like a Barbara. So you can very easily differentiate whether it is the Lena image or Barbara image. The classification, when we keep the spatial values constant, but as it becomes high frequency component, we cannot say classify. There it goes down. Okay. This is fine. So coming to, so our research gap is we must come back or go for a nature inspired algorithms so that we'll be able to classify better, get the performance better. Okay, results will be better. Deep learning models can make use of them. We have already published few papers in IIT Mandi and IEEE Triple IT. Okay, some algorithms, I will also discuss them, how we have done that. Okay. So here we can say that the nature has given or gives back. That's why we call it as nature inspired. Plant to seeds and seeds to plant. A seed is the extraction of the features. See, in case of deep learning, we say that we extract the features. Fine. Nature also extracts the features and keeps it in the mango, and you can plant that and you can get back the mango trees. Okay, so extraction of feature is very important. That's why I'm pressing that extraction of the feature should make use of some transforms like the where the you can reconstruct the original image back and compare so that the performance will be better. Convolution in artificial intelligence, okay, neural network loses the information. I have already discussed now. In convolution, we are going to lose the information. Reconstruction is not possible. When we lose the convolution, when we make the convolution, the weight becomes the floor. I cannot get the floor weight from the floor back. If I have that, what a character in my algorithm, I can perform better. I can perform better. So there are few challenges to reach 100% accuracy in classification. The convolution used in artificial network has no way to get back the original image, original alternative. So an alternative way to be searched to extract features so that the features extracted can be used to reconstruct the original data. Hence classification achieved may reach 100%. Convolution is similar to extraction of oil from seeds, and using oil we cannot reconstruct the seeds. We get groundnut oil. Groundnut oil, I have extracted the oil. Once I extract oil, I cannot get the groundnut back. I give what we call it as waste. One is oil, another one is the waste. I give both. Can we reconstruct it back the groundnut seeds? Not possible because it is crushed. Lossless and lossy techniques of compression can be used in extraction of the features so that the features extracted can be used to reconstruct the original data. And the accuracy of the classification can reach maybe 100%. I have already discussed max pooling is one of the great techniques we make use of. Max pooling is downsampling. Oh. When we downsample, it is here there is a lot of scope for in downsampling, max pooling, the compression. Make use of the compression. Downsample, fine. But whenever needed, I can get back those things. So downsampling layer, you can look into that technique where I compress the data and then make use of the max pooling. Accuracy of the classification always depends on the probability and used by the activation function. Okay. Most of the activation functions, they work on probability. So once we start working on probability, we say that, oh, this is good. Irregular function we make others, the sigmoid function we make use of. So many functions we make use of, all work on probability. Whichever has the highest probability, it says that is the one. See here, in algorithms, I think the Karnataka lottery is banned. Lottery is banned. Today, people are so intelligent, lottery is banned, but they have gone to Supreme Court and they play betting in IPL. IPL, what is the argument, It is a strategic planning. We decide probability and Supreme Court judge permitted. Today we have that no, the boys dream after playing, that they may, have a dream there. Many people have become Kardopati. Crores of people have become lost their assets. The one who has designed that website, he becomes a Karodapati, definitely, because it is a probability. Yes. If it is in limit, like some things which are in limit, they are good for health, like that. If it is in no limit, definitely it is okay. He may get lottery is also like that. One auto driver got 2 crores in Kerala long back. Okay, so